Imagine having the power to look at a building, maybe a bridge,
Yeah.
from way up high and instantly see hidden problems.
Yeah, like a leaky roof that's, you know, about to cause some major damage down the line.
Or maybe a weak spot in the structure itself, something that could become a real hazard.
Exactly.
That's really the potential we're unlocking today on the deep dive. We're exploring the fascinating world of thermal imaging drones.
Mm.
We're going to unpack how these flying heat detectors are, frankly, revolutionizing industries. Think construction, manufacturing, utilities.
Even inspecting our vital infrastructure, it's pretty broad.
It really is.
And what's truly remarkable, I think, is the core technology itself. Thermal imaging.
Right.
It's almost like a superpower, isn't it? The ability to see heat.
Like night vision, but for temperature.
That's a great analogy.
Yeah.
Night vision goggles let you see in the dark, right?
Mm.
They amplify faint light.
Okay.
Thermal cameras do something sort of similar, but instead of light, they detect tiny differences in temperature, heat energy. And they translate this invisible heat into a visual picture. Often you see like warmer areas glowing red or yellow, and the cooler spots look blue.
So you're essentially getting a temperature map.
Pretty much, yeah, a temperature map of whatever the drone is looking at.
And this isn't just about, getting cool-looking images, right? The real power is what that heat information actually tells us.
Absolutely.
These thermal drones, they offer a way to catch problems really early, make operations more efficient, definitely improve safety.
And ultimately, maybe predict when maintenance is needed before something fails catastrophically.
Exactly. Before the big breakdown. Okay, let's unpack this. Starting with commercial construction.
Good place to start.
We're kind of used to seeing drones on building sites now, aren't we? For
Yeah.
things like surveying land, keeping tabs on progress.
Make sure everything's safe, yeah.
Yeah.
Standard stuff, almost.
But now, add a thermal camera to that drone.
Right, and suddenly you've got this powerful diagnostic tool.
So
Well, these drones can fly over a building, say, and pinpoint areas where insulation might be poor, letting heat escape in winter or sneak in during summer.
which is a huge energy drink.
Huge. And they can also detect hidden moisture, water getting in where it shouldn't. That can lead to mold, structural damage.
Nasty stuff.
Yeah, and even find electrical systems that are starting to overheat. That could potentially prevent a fire.
Okay, now here's where I think it gets incredibly interesting. Imagine taking that thermal data
Hmm.
and overlaying it onto a building's digital blueprint. You know what they call BIM, Building Information Modeling.
Ah, yeah, BIM. The detailed 3D digital model.
Exactly. So if you can see a real-time thermal picture mapped right onto that digital model.
Wow, okay. That gives you an incredibly rich understanding of the building's actual performance. Not just the design, but how it's really working.
And not just for single buildings, right? Think about large-scale commercial developments or even city planners trying to grasp the energy efficiency of whole urban areas.
Precisely. And if you connect that back to the practical benefits on a construction site right now, well, safety is huge.
How does it improve safety?
A thermal drone can inspect scaffolding, look for potential weaknesses, check high areas, all without putting a human inspector in a potentially risky situation.
Right, keeps boots off the ground or off the high beams.
Exactly. And then there's the money side.
Mm-hmm.
Catching construction mistakes, like that poor insulation example, or water leaks, catching them early.
Before the walls get closed up.
Right, before it's all finished.
Yeah.
Fixing it then can lead to substantial cost savings. You avoid ripping things out and doing expensive rework later.
Imagine spotting missing insulation before the drywall goes up.
That's a fraction of the cost compared to tearing down finish walls later.
Yeah.
Massive difference.
Okay, it sounds fantastic, almost like a no-brainer. But what are the challenges? Why isn't everyone doing this all the time?
That's a really important point. It's not quite that simple yet.
Yeah.
First, the initial cost. High-end thermal drones and those specialized cameras, they can be a barrier for some companies.
An investment, yeah.
Definitely. Then, you need trained people who not only know how to fly the drones safely and capture good thermal images.
Which isn't trivial itself.
Not at all. But critically, they also need to understand how to interpret that thermal data.
It's not just red means hot, blue means cold.
Not always, no.
Yeah.
It's more nuanced. You need context.
Mhm.
You need to understand what you're looking at, what the normal heat pattern should be.
Okay, that makes sense. Expertise is key.
Absolutely.
Yeah.
And let's not forget the rules. Regulations. Navigating airspace restrictions, especially in busy urban areas.
Near airports over cities.
Yeah, that can be complex. You need the right permissions, the right procedures.
Okay. But looking ahead, what's the future look like in construction for this?
Oh, the future's exciting. We're seeing really rapid advancements in AI, in artificial intelligence.
How does AI help?
It can be trained to automatically analyze thermal images and identify common defects. This could make the interpretation process much faster, less reliant on human experts for, say, routine checks.
So speed things up, make it more accessible.
Exactly. And looking even further out, you can envision drones becoming fully autonomous, just seamlessly integrated into the construction workflow.
Doing regular scans on their own?
Yeah, performing thermal scans automatically, flagging potential issues without direct human control. Companies are already working on this stuff.
Wow. Okay, let's switch gears a bit. Let's talk about the industrial sector. Factories, refineries. It sounds like thermal drones could be incredibly valuable there, too.
Oh, absolutely. In those kinds of industrial settings, they're being used to inspect all sorts of things. Manufacturing equipment, complex machinery, oil refineries, storage tanks.
What's the main goal there?
The primary focus is usually monitoring the temperature of critical equipment, looking for anomalies,
Like what?
like, say, a bearing that's overheating in a big motor, or maybe a section of a pipeline showing an unusual temperature reading. These can be early warning signs.
Signs of impending failure.
Exactly. Catching it before it breaks down completely.
So what kind of improvements or opportunities does this open up for the industrial world?
The potential is significant. Regular thermal checks allow for what we call predictive maintenance.
Using data to predict problems.
Precisely. You anticipate when equipment might fail, so you can fix it proactively during scheduled downtime, not.
Not when it unexpectedly grinds everything to a halt.
Right. That minimizes unexpected downtime, which in a factory or plant can mean huge cost savings. Think about an assembly line stopping suddenly.
Yeah, that costs a fortune every minute.
It really does. So if a thermal drone spotted that motor overheating during a routine check, maintenance could have been scheduled. No costly disruption.
Makes perfect sense.
And there's also the exciting possibility of integrating these drones with other smart sensors. The Internet of Things, IoT devices.
Creating a whole network.
Yeah, a really comprehensive monitoring system across an entire industrial facility, seeing the whole picture.
That sounds like a massive win, both for the company's bottom line and, importantly, for the workers in those, let's face it, often hazardous environments.
Absolutely. Beyond just preventing downtime, these thermal drones really enhance worker safety.
How so?
Well, they can inspect things like high-voltage electrical gear or areas with extreme temperatures or confined spaces without needing a person to go right up close.
Reducing risk.
Significantly reducing the risk of accidents.
Yeah.
Keeps people out of harm's way.
Okay, so what are the specific challenges in applying this in the industrial sector? Is it similar to construction?
There are similarities, but also some specifics. A key challenge, maybe even more so than in construction, is the need for really specialized expertise in interpreting the thermal data.
Why more so?
Industrial equipment often generates very complex heat signatures, different machines, different processes. Understanding what's normal, what's abnormal, what a specific pattern means, that takes real training and experience.
So you need skilled pilots, but even more, you need skilled analysts.
Exactly. People who can look at those thermal images and translate that complex data into clear, actionable maintenance decisions. That's crucial.
And what kind of advancements are we seeing on the horizon for these industrial uses?
Well, we can expect software to get better, more intuitive, more user-friendly interfaces, making real-time analysis easier and more accessible.
Lowering the barrier to entry a bit.
Hopefully, yeah.
Yeah.
And as the technology itself continues to improve and, crucially, becomes more affordable, we'll likely see much wider adoption across all sorts of industrial sectors, leading to safer, more efficient, more reliable operations overall.
All right, let's turn now to utilities. Power lines, substations, pipelines. This seems like another area where thermal drones would be incredibly useful, especially given the scale of that infrastructure.
Oh, they're proving to be invaluable there. Utilities are increasingly using drones, definitely, inspecting those vast networks of power lines, electrical substations, pipelines. It's a huge job.
And thermal imaging is key.
It's particularly crucial, yes, because it can detect components that are overheating.
Which is a bad sign.
Often a very bad sign. It usually indicates a potential failure point, like a loose connection on a power line, maybe, or a failing transformer in a substation.
Things you definitely want to catch early.
Absolutely. Catching these can prevent power outages or even more serious incidents like fires or equipment failures. It's about reliability and safety.
Are there new applications emerging for utilities or ways they're expanding its use?
Yes, definitely. There's significant potential in the renewable energy sector.
Ah, like solar farms.
Exactly. Imagine using thermal drones to efficiently scan huge solar panel farms. You can quickly identify individual panels that are underperforming because some cells are overheating.
Instead of checking each one manually.
Precisely. Or inspecting wind turbines, looking for unusual heat signatures in the gearbox or the bearings up in the nacelle. Again, predictive maintenance.
Makes sense.
And beyond inspection, there's a possibility of real-time monitoring, allowing utilities to respond much more rapidly to any anomalies detected anywhere in their system.
Quicker repairs, less disruption.
That's the goal.
So thinking about, someone at home relying on these services, what are the main advantages for the consumer?
Well, from the consumer's point of view, the biggest benefits are probably more reliable services.
Fewer power outages?
Fewer unexpected power outages, yeah.
Ah.
Or fewer interruptions in gas or water supply. That proactive maintenance, enabled by these drone inspections, leads to a more stable, more resilient infrastructure for everyone.
And presumably, cost savings for the utility might eventually benefit customers too.
That's the hope. It certainly leads to cost efficiencies for the utility companies. It reduces the need for traditional inspections, climbing poles, using helicopters, which are costly and time-consuming.
And dangerous.
And dangerous, yes.
Mm.
And it helps prevent those major equipment failures that can be incredibly expensive to fix.
Okay, but are there limitations? What challenges do utilities face using this tech?
Yes, there are definitely challenges. Weather is a big one.
Can't fly in storms?
Right. High winds, heavy rain, even thick fog can ground the drones. That limits when inspections can happen. Also, the sheer volume of data these drones collect, especially over vast networks, can be overwhelming.
Managing all that information.
Exactly. Effectively managing it, analyzing it, and then integrating that data smoothly with their existing utility management systems. That's a considerable technical challenge.
I can imagine. Looking ahead then, what improvements can we expect for utilities?
We can anticipate drones getting better, naturally. Longer flight times, better endurance, maybe more capability to operate in less than perfect weather conditions.
More resilience.
More resilience, yeah. And we'll also likely see big advancements in data analytics, more sophisticated software tools that can automatically process and interpret the thermal data.
Making better predictions.
Providing even more accurate predictions about when and where maintenance is actually needed, making the whole system smarter.
Okay, now let's consider our public infrastructure. Bridges, roads, tunnels, the structures we all rely on every single day. How are thermal drones helping monitor their health?
They're being used more and more there, too, for inspecting bridges, roads, retaining walls, other critical structures.
What can thermal actually show you on, say, a concrete bridge?
Well, the thermal imaging can sometimes reveal hidden weaknesses within the materials. These might show up as subtle temperature variations.
Caused by what?
Could be caused by stress, moisture getting inside the concrete or asphalt, or something called delamination where layers start to separate, things you can't easily see on the surface.
Hidden problems again.
Exactly. It's about seeing beneath the surface.
What about future applications here? Where could this technology go in maintaining our infrastructure?
Oh, the potential is immense. Imagine integrating thermal drone data into those smart city initiatives we hear about.
Continuous monitoring.
Yeah, potentially continuing real-time monitoring of the structural integrity of key infrastructure. Getting early warnings of potential problems long before they become safety hazards.
That would be huge.
It really would. And think about disaster response. After an earthquake or a major storm, thermal drones could be invaluable.
How so?
For quickly assessing damage to bridges, roads, buildings, identifying stable versus unstable structures. It could help prioritize rescue efforts and speed up recovery planning.
Wow, okay. So ultimately, how does this benefit the public, us?
Well, the primary benefits are pretty clear, I think. First, increased safety, catching potential structural failures early before they become dangerous.
Preventing collapses or major issues.
Hopefully, yes. And second, more efficient use of our tax money.
Wow.
By providing accurate, detailed data on the actual condition of the infrastructure, maintenance resources, money, crews, materials can be directed precisely where they are most needed.
Instead of just guessing or doing scheduled replacements that might not be necessary yet.
Exactly. It allows for much more targeted and effective maintenance rather than relying on less precise or purely reactive methods.
Makes sense. But what are the hurdles here? Why aren't we seeing this everywhere already for infrastructure?
Well, implementing this on a really large scale across entire road networks or all the bridges in a region, that's a significant investment.
Cost again.
Cost is a big factor, yes. Both the drone hardware, the software, and importantly, the specialized expertise needed to operate the systems and properly interpret the data for infrastructure.
And maybe getting different agencies to work together.
That's another big one. Coordinating the efforts of various government agencies, different departments, different stakeholders involved in managing infrastructure, they can present real logistical and administrative challenges. Getting everyone on the same page, adopting the same standards.
Yeah, bureaucracy can be tough. But what does the future hold here? What developments are coming?
We can expect to see, hopefully, the development of more standardized guidelines and best practices for using drones in infrastructure inspection. That should help streamline adoption.
Make it easier for agencies to implement.
Right. And we're also likely to see increased government funding and support for these kinds of technologies as the long-term benefits, the safety improvements, the cost savings become more and more apparent and proven.
Okay, great. Now, before we wrap up, there's another really interesting piece of tech that often gets used with drones and sometimes gets confused with thermal imaging. That's LiDAR.
Ah, yes, LiDAR. Good point to clarify.
Let's take just a moment to understand the key differences between thermal and LiDAR and why knowing that difference really matters.
Absolutely, it's crucial. So, as we've been discussing, thermal imaging, or infrared, it's all about detecting heat, right? Temperature differences.
Yep. Sees heat.
Everything emits heat, and the camera visualizes those differences. Now, LiDAR is fundamentally different.
Okay.
Instead of heat, LiDAR uses light, specifically lasers, to measure precise distances to objects.
Lasers. Okay, how does that work?
Well, imagine shining a very, very rapid pulse of laser light at something and timing exactly how long it takes for that light to bounce back to the sensor.
Like sonar, but with light.
Kind of, yeah. LiDAR does this millions of times per second, sending out pulses in all directions.
Yeah.
And by measuring the time of flight for all those pulses, it builds up an incredibly dense and accurate three-dimensional point cloud of the surroundings.
A 3D map made of points.
Exactly. And it's incredibly precise, often accurate down to the centimeter level.
Okay, so thermal sees heat patterns, LiDAR measures shape and distance with lasers.
Got it.
Yeah.
Can you give some practical examples of what each is best suited for?
Sure. Let's think about that leaky flat roof again.
Okay.
Thermal imaging is great for finding the cool spots where moisture might be trapped inside the insulation. It sees the temperature effect of the water.
Right.
LiDAR, on the other hand, wouldn't see the water inside, but it would be excellent for creating a highly detailed 3D model of the roof's surface itself. Maybe measure its exact dimensions, check for sagging or structural deformation.
Different information entirely.
Completely different. Or spotting an overheating electrical panel.
Thermal will definitely see the heat. Exactly. Thermal is your go-to. You'll see the hot spots indicating a fault. But if you need to create a really accurate map of a construction site before you start mapping the terrain, existing features,
LiDAR.
LiDAR would be the ideal tool for that precise topographic mapping.
Okay, one more. Checking solar panels.
Checking if solar panels are performing efficiently by looking for overheating cells. That's thermal imaging again. Heat anomalies tell you about performance issues.
And what about monitoring, say, tiny movements in a bridge over time?
Oh, that would be a key application for LiDAR. Its ability to make incredibly precise measurements over time could detect subtle shifts or movements that might indicate structural stress, something thermal wouldn't see.
That makes the distinction really clear. So it's definitely not a case of one being better than the other.
Not at all. They're complementary tools. Different tools for different jobs.
Powerful technologies, both can be mounted on drones, but they give you very different types of data.
Exactly. And understanding those differences is absolutely key to choosing the right tool, or maybe even using both tools to get the information you actually need.
Right tool for the job. Okay, so to kind of bring this deep dive to a close, it seems really evident that thermal imaging drones, specifically, are having a truly transformative impact across a whole range of industries.
They really are. They offer this powerful combination of improved safety, greater efficiency, and often real cost effectiveness when it comes to inspecting and maintaining all sorts of critical assets.
Things we rely on every day.
Absolutely. And for you, the listener, maybe take a moment to consider how this technology, thermal imaging drones, might apply to your own field.
Yeah, whether you're involved in construction, manufacturing, utilities, infrastructure management, maybe something else entirely.
The potential for these drones to provide valuable, previously hidden insights is just immense. We'd really encourage you to explore the possibilities, stay informed about the advancements. It's a really dynamic area.
It certainly is. And maybe a final thought to ponder as we wrap up. Beyond all the applications we've discussed today, what other hidden issues, things currently invisible to our naked eye, might this thermal technology one day help us uncover and address in the future?
Good question to think about.
Thanks for joining us on this deep dive.